In this video, I'll be describing the structure of the nucleus. Remember that in the nucleus there are two subatomic particles, protons and neutrons. So let's just quickly review a couple of vocabulary terms associated with those particles. The atomic number of an atom is equal to the number of protons in its nucleus. This should be memorized. The atomic number is equal to the number of protons. The mass number is equal to the sum of the protons and neutrons added together. Another statement to be memorized. Mass number is equal to protons and neutrons. In this lesson, we'll be looking at models that represent the nucleus of atoms, and we'll be building models to represent the nucleus of different atoms. Let's look at an example problem. In this problem, we're asked to make a model of helium-4. We'll use our periodic table to help us remember that helium has an atomic number of 2. When you see the word helium followed by a number, that number represents the mass number. So we need to make a model of the nucleus of a helium-4 atom. Since it's helium with atomic number 2, it must have 2 protons. So I'm going to add 2 protons to the nucleus. Now, how can we make the mass number equal to 4? Mass number is the sum of protons and neutrons added together. We already have 2 protons, so we only need 2 neutrons. Here you can see that this model represents the helium-4 nucleus. There's 2 protons, which correspond to an atomic number of 2. There's 2 neutrons, so the sum of protons and neutrons together is 4. In other words, there are 4 nucleons inside this nucleus. Let's try another example. Here we're asked to make a model of the lithium-7 nucleus. We'll use our periodic tables to see that lithium has an atomic number of 3. Thus, we need 3 protons. Now, take a second to think about how many neutrons must be added to this nucleus so that the mass number is equal to 7. Remember, the mass number is the sum of protons and neutrons. There are already 3 protons, meaning we need to add 4 neutrons to this nucleus. Here I have made a correct model to represent the nucleus of lithium-7. Here's another example. Make a model to represent the nucleus of beryllium-9. Take a second and think of how many protons and neutrons must be added to the nucleus. Beryllium is atomic number 4. I'm adding 4 protons. I'll need to add 5 neutrons, so that the sum of protons and neutrons together is 9. This represents this model correctly represents a beryllium-9 nucleus. It's beryllium because there are 4 protons, and beryllium is atomic number 4. And with 4 protons and 5 neutrons together, the mass number is 9. Try some example problems on your own.